All right, good morning, everyone. Welcome to our Malagasy Scientist Speaker Series. My name is Megan McGrath, and I am hosting from the Duke Leamer Center in North Carolina. And I will be here to facilitate questions. If you have them, please go ahead and write them in the chat as we have our speaker today. But without further ado, I will pass it over to my colleague, Marie Roland in Madagascar.
Hello, everyone. My name is Marie Roland Swazafi. I'm a Malagasy scientist from the University of Cursa in northeast of Madagascar. And today we are happy to welcome our speaker, Zara Randriamanakoto. She's a Malagasy scientist, a lecturer at the University of Cape Town in South Africa, and also a researcher on the astronomy department. And she is also a lecturer in the University of Antananarivo and a founder of an association, Malagasy Astronomy and Space Science. And she is also an active member of Galastem Association in Madagascar. And this talk series exists thanks to the Duke Africa initiative and thanks to the support from Duke Leamer Conservation Center. We are happy to welcome you, Dr. Zara.
Okay, so does that mean I can start now?
Yes, please do.
Okay, yeah, so hi everyone, and thanks Marie Swazafi for the introduction, and Megan as well. And thanks for the invite to be part of this seminar series. And maybe before we begin, I would like to make a small correction. I'm no longer based at the University of Cape Town, but the South African Astronomical Observatory, being a staff astronomer there. But yes, I used to be a postdoc at the University of Cape Town. So to begin with, and I would also like to say hello to all the students that are based in SAVA, and hope that this talk will inspire you to become a scientist, not necessarily an astronomer. Let me share my screen so that we can start. Okay, so can you see my screen fine?
Yes, it looks great.
Okay, yeah, so the main component of my talk will be on my research, young massive star cluster in a sample of strongly star-forming galaxies. But if time permits, I will talk a bit about the astronomy in Madagascar, the current landscape, and also about the Galastem, another association which I co-founded in 2016. But first thing first, let's talk about research. My research topic is not only about young massive star cluster, but I'm also interested about galaxy evolution, which means that I'm also studying remnant and restarted radio galaxies. But today I will focus on young massive star cluster, which I spend almost 70% of my time as a researcher. And the main reason why I'm interested to study this type of object is I would like to understand the star formation in general by assessing the University of cluster formation and disruption mechanism. I will talk more about it later, but just so you know, it's really a broad range of multi-wavelength research that I'm doing, from optical using VLT, Gemini, the Hubble Space Telescope, to infrared Spitzer, X-ray Chandra, and also South African-based telescopes such as SALT and Meerkat telescope. This work is not possible unless I did collaboration with few people based in South Africa, such as Petri Väisänen, but also other colleagues in Australia and in Finland, as well as the Sambar team. I'm also actively supervising students based in South Africa, but also in Madagascar especially. So there is Francie, Julio, and currently we are busy finalizing the master thesis of Murarakutaf. So all 5 students are working on star clusters. I didn't include students that are working on radio galaxy. For those of you who are not yet familiar, when I say young massive star cluster, I will first give a brief introduction. When we talk about star clusters, there are mainly, we always hear open clusters and then globular clusters. Open clusters usually refers to objects such as the Pleiades. I'm sure you've heard a bit about it. And globular clusters, that's among the oldest objects in the universe. And what differs the two type of star clusters? One has only a few mega-year of age and loosely packed star, whereas globular clusters, they are really very dense and they can reach up to 10 to the power 6 solar mass. And since the launch of the Hubble Space Telescope in 1990, around 1990s, a new type of star cluster has been discovered, and that's the young massive star cluster, but you can also call it YMC or young massive clusters. It fits in between the two types of star cluster because it has similar property in terms of density, with respect compared to globular clusters, but in terms of age, it is still very young. And why are we interested in studying this type of object? It's because, remember at the very beginning of this talk, I said we are interested in understanding the whole star formation mechanism in the universe. How do stars form? So by studying YMC, we would like to understand why most of the stars, they form inside the star clusters, but then as they evolve, they will scatter and some will become field stars. And because they are always seen in region where star formation is very high, that makes them a very good tracer of recent star formation. And as you can see in the previous slide, because of the similarity with globular clusters, they are also believed to be young progenitors of globular clusters that are still forming today. And one of the reasons why it's important to study and useful to study these YMCs, because they can be seen in most different types of galaxies, such as our own Milky Way, also starburst dwarf galaxies, and as well as gas-poor spiral galaxies. But in my own research, I'm mostly interested at strongly star-forming galaxies. When we say strongly star-forming galaxies, that means they have a very high star formation rate, such as starburst galaxies, luminous infrared galaxies, as well as collisional ring galaxies. If we use the infrared luminosity of the galaxy to specify the range, then we are looking at a range between 10 to the power 6 to 10 to the power 12 in terms of infrared luminosity. And one of the most well-known luminous infrared galaxies is the antenna because of its shape. And when you study YMCs, it's one of the great prototypical galaxies. Just a brief overview. When we talk about LIRGs or luminous infrared galaxies, these type of galaxies are very interesting because as we move from today until the redshift around 2, they are very rare. But when we reach redshift around 1, they become really predominant, and their luminosity can reach up to 100 times the luminosity of our own galaxies, the Milky Way, and they have an energy about 90% that emits in the infrared wavelength, and hence their name luminous infrared galaxies. And one thing that makes them very interesting as well, they are mostly interacting, which means that there is a system of two galaxies that are entering and having an interaction. When we talk about collisional ring galaxies, there is a ring because of the name ring, and because of collision between a companion and the main galaxy, there is a ring that forms as a halo, and that ring contains a lot of gas and stars and can have a diameter up to 100 kiloparsec. The image you see here is a simulation that was developed by Rappaport et al. In 2010 to simulate how does a collisional green galaxy form as a companion galaxy enter and disrupt the whole disk of the galaxy, and by the end, at the end, it forms the ring where I've shown here. So it's a result of a collision between two galaxies as well. So yes, these objects are worth to be studied, and especially a good laboratory is to study YMC, because whenever there is star formation, we would expect young massive star clusters to form, and in such star galaxies, the rate of star formation is quite high because of the displacement of gas. What are the main results and the main findings that have been done in the field of YMCs, especially in nearby star-forming galaxies? Here, I'm showing a plot of the brightest star cluster with respect to the star formation rate of a galaxy. So each data point corresponds to one galaxy and its brightest star cluster. And the expectation is that if there is no influence of environment, then we would not see a tight scatter as the one we see here. But then what we see, which was a main finding that we found in 2013, there is a tight scatter by deriving the first ever star formation rate and brightest star cluster. And the same thing here, if you plot the cluster formation efficiency, which means the amount of stars that form inside star clusters, there is also a tight correlation with respect to the star formation rate density. And the third plot is the truncated mass cluster, the truncated mass versus the star formation rate density. So what makes these three plots similar is that they all present a hint that if there is just a statistical effect, we wouldn't see a tight scatter or the shape of the star formation rate density increasing with the cluster formation efficiency as well as the truncated mass cluster. So this is one of the reasons why the open questions still remain. Which fraction of stars really form inside clusters, and how important is it, the influence of the host environment on the formation and disruption mechanism of the YMC? And this is why in my research, I'm mostly interested in answering such questions. So one of the projects that I currently recently just published and still in press is the YMC in the Sambar survey. Sambar is an acronym of supernovae and starbursts in the infrared. It was to imagine near-infrared adaptive optic image using the very large telescope in Chile and the Gemini Altair as well as GEMS. It consists of imaging using that telescope around 40 starburst galaxies and learn with a star formation rate that spans between 7 and 170 solar mass per year. The resolution is almost the same as the resolution of the Hubble Space Telescope, which means 0.1 arcsecond. So what you see here is an image of all of these galaxies in the near infrared, and this plot is just showing you basically the infrared luminosity versus the distance of this target. So we are looking at target having distance between around 20 up to 200 megaparsec. Why is it worth to study these galaxies using near-infrared telescope? Simply because if you look at the bird galaxy. So the bird is a luminous infrared galaxies, which consist of 3 galaxies that are interacting, and one shape, one morphology of it looks like the head of the bird. If you look at it using the Hubble Space Telescope, for instance, here the ACS camera, which means then that up to optical wavelength, we can't see much because of dust. But once you move to the near infrared, you can clearly see that there are complexes of YMCs. So you can really see from there the capability using near infrared telescope. And after doing all the preliminary data reduction and analysis, now we plot the luminosity function of cluster population in each galaxies. And after plotting that, you can fit it with a power law function, which is among the most well-known function that best fits the cluster luminosity function of a star cluster population. And what you see is a trend where a galaxy with low star formation rate has high value of the slope, but as you go to higher star formation rate, it becomes shallower. At this stage, you can't say much yet because it could simply be a statistical bias. So this is why we also plot the parameter alpha, or the power law slope, with the the specific star formation rate, which is the star formation rate divided by the stellar mass, as well as the power law slope plotted against the star formation rate density. And the more we use these two quantities, which are less prone to statistical effect, the more the relation becomes more pronounced, because you can see from the correlation factors, it varies from minus 0.34 up to minus 0.64. We also tried to look at any over correlation with respect to the host properties of the galaxies, but you couldn't see much. We only saw it from the star formation rate indicator. So another way to check how much does the environment influence the cluster population in the galaxy is by splitting the population in 2 different subpopulations, which means the galaxy next to the nuclear ring against the galaxy in the outer region, for instance, the spiral ring. And what you see there is that the value of alpha in the nuclear regions are shallower than the value of alpha in the outer region. And here, by doing that, we also only considered galaxies that have star clusters more than 300 or 200 star clusters to avoid, once again, statistical bias. And this study was done as part of the project of Giulio and Gianzaffi. As part of the study of YMC, we also sometimes only look at one individual galaxy and make a comprehensive study, which means that we also derive the mass and the age of each star cluster population to see how much does environment influence the life scale, the lifetime of a star cluster. And what we see through these 2 plots, which is the mass function and the cluster mass versus the galactocentric distance, closer to the nuclear ring of the nuclear radius, the nuclear region of ARC-299, the galaxy that we are looking on your right panel, you can reach up to 10 to the power 7 solar mass. But then as we go farther away, the mass decreases. That means that when there is a lot of gas, such as in the nuclear region, it really gives a boost to the formation of the very massive star clusters. Away from that region, we can get 10 to the power 5. Why there is this slight increase? Because this point is where the 2 galaxies, which is NGC 3690 East versus NGC 3690 West, that's where the point of contact, and once more again, a boost in the formation of a massive star cluster. And One key point that you could get through this study is that, yes, the cluster mode of formation and disruption is definitely environment and mass dependent. The more a star cluster resides in the nuclear regions, the more they can become very heavy, but then they can also then easily get disrupted and less likely become globular clusters. One project that we are currently finalizing is as part of a master's project of Murarakoto. And in this case, we are focusing on a collisional ring galaxies called ARC-147. Each blue dot that you see is a star cluster. And what you would like to understand is to see whether the age and the mass of each star clusters, how is it affected with respect to the ongoing, that the past interaction that happened around 50 mega year ago with this companion galaxy. When we say would like also to understand the star formation mechanism in the ring, there is two scenarios that may happen. Either a popcorn scenario, so it's just a random position. Any region of the ring can form a star cluster, and the pearls on a string scenario, it means that any region with over-dense star formation, over-dense gas are predominantly hosting star clusters. We cannot dissociate the two factors unless we will be deriving the age and mass of the star clusters. But right now, by only looking at the CMD, cluster magnitude diagram, and the spatial distribution, we can get an approximate range that varies between 10 to the power of 5 to 10 to the power of 7 solar mass for the mass of the clusters, and an age that is more or less less than 100 megayear. So to summarize the work of young massive clusters, one, yes, near-infrared adaptive optic image are definitely useful to study those YMC candidates that are sometimes hidden by the optical dust, especially if they live in the nuclear region. And YMCs are definitely good tracer of recent small-scale star formation, since they are the most massive and extreme form of star formation. So based on this finding so far, there is likely an influence of the galaxy environment in the cluster formation and disruption mechanism. But one thing that I would like to draw your attention, before we could make those discussion and take up in conclusion, all biases and possible uncertainties have been thoroughly investigated, especially resolution bias, especially if you are looking at the galaxies that is a bit farther away from us, and therefore a star cluster will not be seen, two star cluster will not be seen as a complexes instead of individually being resolved. So what's next in terms of YMC? We would want to image the mass and the age of YMC and also understand the star formation history of ARC-147. And after all that, yes, we will publish our result. And one thing that I'm currently busy is to leverage being a staff member at SAO, applying for them at SALT, or the Southern African Large Telescope, which is the largest optical telescope in the Southern Hemisphere. And another project that I'm currently developing is also the multi-band study of a sample in the Southern Hemisphere for the collisional ring galaxies. So that's what I'm currently busy most of the time, my own research, but I'm also actively involved in the advancement of astronomy in Madagascar as the founding president of Malagasy Astronomy and Space Science, as well as the National Outreach Coordinator of the IAU, the International Astronomical Union, Office for Astronomy Outreach. And I will just show one slide about Orion Astrolab, which is the reason why By the way, I'm currently in Madagascar because I just implemented this project last week. If you talk about astronomy in Madagascar, that means the era of 1889, just before the colonization in 1996. This is when some Jesuits, they established the observatory of Ambutepun. For those of you who know the University of Antananarivo, there is Ankats and then there is Ambutepun. So it's just nearby, and this observatory is still there, although the telescope is no longer in use for research, but for outreach. But there was a revival in the advancement of astronomy thanks to Madagascar becoming a partner of South Africa as part of the Square Kilometre Array. Square Kilometre Array is the largest radio telescope that will be built around the world. In fact, it's currently being built, and because of this cooperation, partnership between the two countries, there were students like myself that were sent in South Africa to have learn more about astronomy. And here it was like back in 2013, and I would like to draw your attention. It was only one female, myself, against 7 males. So yes, definitely astronomy and the other science STEM field really need some boost on how to promote science to women, and I will talk later about it. Since 2014, because of the cooperation, there was also the will to develop a curriculum of astronomy at the University of Antananarivo. So for those of you, if you are a student based in Madagascar, if you have a passion in astronomy, know that you can have a master's degree at the University of Antananarivo, and the figure you see here is the enrollment since 2014 until 2020. And in 2014, there were only 7 males. It was only in 2016 that there were 2 females, and then the number changed. In 2017, it was 4 females and 1 male, and so on. Thanks to Professor Minson Rakutumalal, he is the one who initiated the Astronomy MSc program, and currently the head of the astrophysics research is a colleague used to study with me in South Africa, Dr. Zara Randriamanakoto. The research areas that you can do as a master's student can range from extragalactic astronomy, or particularly radio astronomy, to cosmology, as well as instrumentation. And we, the ones who already received our PhD, are the ones that are supervising students that are registered under the MSc program. And because the MSc program is still relatively new, there was a need to support the student, and hence one of my motivation in 2016, along with Lianzu and Nanjian, they are currently PhD students in South Africa, to launch and create the Malagasy Astronomy and Space Science. And currently it's a network of professionals, students, and amateur astronomers. And our vision is to become a trademark of astronomy in Madagascar, and with a mission to promote science and astronomy in Madagascar. So in terms of members, the professional, we are 10 of them, and our main mandates is to support student members. For the student, we call it student member. If you are a master's student, there are currently around 25 members, and they mainly support the amateur members. And to date, we have 73 members that are not that can range with different background, from someone doing law or economy or art. It's really diverse, and they can participate in public outreach events. I just like to emphasize one of the project under the Malagasy Astronomy and Space Science, which is the mass annual workshop, because it's really a way to give support to the student so that by the time they do their research project, they are familiar, for instance, with Python programming or Linux, getting used with Linux commands, but also soft skills that are needed in completing the research. This year, in 2022, we will hopefully run the 5th edition. We had our very first edition back in 2017. It's a 3-day intensive workshop, and the lecturers are the professional members. They either come, depending on the travel restriction. We all know COVID, but sometimes they also enter online to deliver their talks. Two big milestones in terms of astronomy in Madagascar is also the very first ever astronomy conference that was held in 2018, thanks to the ADI project. Back then, when I used to be a postdoc with them, so convincing, come to Madagascar. Not only you will see how beautiful is the country, because after the conference, most of them went for tourism to get to know more about Madagascar. But again, it was really a way to remind the government or all key stakeholders that astronomy is really getting real, and it really needs the support of local government. In 2018, that same year, I attended the General Assembly in Vienna, because through a proposal, Madagascar was now accepted as an observing member of the International Astronomical Union, which is the network or the international network of astronomers that are around, I think the number is now 15,000. And one vision that we would like to implement is to launch a network of Malagasy amateur astronomers this year, 2022, by the end of this year, because so far there are only 2 well-known astronomy associations in Madagascar. The one that I co-founded, Malagasy Astronomy Space Science, and the colleague from Aikitana Astronomy. So Aikitana means astronomy in Malagasy. This office, I would not call it an association, because the whole idea is for it to link all association with the IAU Office for Astronomy Outreach. And this is why, as I said earlier, the implementation of the Orion Astrolab. So this picture was just taken last week, where we were training around 20 amateur astronomer, passionate student or teacher who would like to become Astro Club leaders. And we made sure that they were representative outside Antananarivo, because we would really like to decentralize astronomy. Like him, he comes from Diego and Tsiranana. There was one representative also from Fianarantsoa, 2 of them, and then Tsirumandidi, Ambatolampi, Ambustra. And there was also one from Toliara, but then unfortunately she couldn't come. We taught them how to conduct an activity, but you also taught them what are the soft skills needed for your Astro Club to really thrive, because that's always the problem. It's easy to start, but if you don't get the basic skills, then it won't last not even a year. So that's one project that is currently still ongoing. To end my talk, I would like to talk just a little bit about Galastem, or Gala Science, Technology, Engineering and Mathematics. I showed that picture where there was only one female student, me and my other colleague. You can really see then that the number, the 30% only women scientists, it's really a number that we really need to change. And this is why we founded, me and Jan Charakutrnirina, a primatologist, in 2016. And it's a voluntary non-profit association that is registered in Madagascar, and it's fully led by early career Malagasy women scientists. Why launch the Galastem? Because of three main reasons: to fix the leaky pipeline. It's not that there were girls who are not interested in science. It's there. It's just that by the time they reach to the university, we cannot find them, or the number really becomes very low. And you definitely need to fix the gap. Why there is this gender gap in STEM? So that's one reason. The second reason is the lack of young female role model in STEM in Madagascar. When you ask someone who is your role model, they will always look for someone outside Madagascar. So by having a platform that regroups all the early career female scientists, now they can have a visibility, and it will be a way for the young girls, and not even girls, but even male students, to associate because they have the same similar background. And the third and main reason also as a personal motivation, because I'm currently based in South Africa, I'm doing astronomy. Most of them people ask, why is it important to Madagascar? So it's a way for me to keep my feet on the ground while reaching for the stars, and also to contribute while I'm outside Madagascar as a diaspora. And it was really a crazy dream that was turned into reality. Our targets and audience, as I said earlier, girls in primary, secondary school, those are our primary targets, as well as the women graduates and early career in STEM. But of course, if you want to tackle the problem of gender gap, you also need to reach out to school teachers, parents, local governments, and as well as the general public. I'm putting this quotation here: when solving problems, dig at the roots instead of just hacking the leaves. So this is why we really invest right at the primary school, not wait for the women to reach out to reach their tertiary education. I'm not going to go through, but what I would like to draw your attention is the way we manage Galastem. We split it in different chapters. So there is a chapter in Asia, that's the newest chapter, in Africa, in America, in Europe, and in Madagascar. We split Africa and Madagascar, since Madagascar is our hub and where the headquarters of Galastem. For your information, to those of you who are interested in studying in Asia, right now the chapter in Asia are organizing a seminar, so have a look at our Facebook page because they are advertising it right there. And we also have committees such as the membership, communication, finance, and fundraising, and all of those are managed by volunteers. We do not have staff yet at this stage. The type of activities that we offer, it can run through school outreach or science fair. We also produce STEM magazine as well as running mentoring program. For the chapter in America, they are the one in charge of the Galastem small grants as well as the mentoring program. We also run soft skills training, fellowship program, and launched the very first celebration of the International Day of Women and Girls in Science in Madagascar. What are the milestones so far? So Galastem was founded in 2nd of May 2016, which means that within those 6 years of existence, we have have 560 registered members that are spread in 5 chapters and at least 13 countries. There are at least 3 sub-chapters in Madagascar, so that's Fianarantsoa and Tsirabe and Ambositra. And for operational committees, at least 40 projects have been implemented, and we also collaborate with both local and international NPOs. Initiation of the IDWGS, the International Day of Women and Girls in Science. So we really do our best to always organize an event around that date, even be it small or big, depending on the funding available. And we will really leverage social media. We have 15,000 organic followers. We never boost our page, but we really have a strategic plan to make sure that our followers are engaged. So recommendation and the lesson learned in terms of Galastem, at the very beginning, I didn't think it was really going to be this big. So one thing that I will really definitely say and keep like as my motto, think big, but start small. And it's okay to be ambitious as long as you are realistic. When you run a mega project like Galastem or even the Malagasy Astronomy and Space Science, just be aware that it's not a sprint, it's a marathon. So you really need to learn how to organize your time and really work on your strategic plan. And if it is driven by passion, not by over motivation, it will likely succeed, because by being passionate, you will easily inspire like-minded people in your circle, and because you work together, you leverage your team members' strength and expertise. Don't forget to delegate and be flexible. That's one thing I'm sure we all learned through COVID-19, that always have a plan B, because things can just change in a minute. So yes, sharing is the best way to learn. This is why I don't see a point of doing anything if afterwards I'm not willing to share, to learn, be it in my research, my involvement for the advancement of astronomy in Madagascar, or also the Women in STEM with Galastem. If you are interested to collaborate or support our initiative, don't hesitate to reach out to me via email, and you can also follow me on Twitter. Thank you very much.
Thank you so much, Zara. So I will give a few moments to see if Marie Roland has any questions with her students. Yes, I see a nod. Great.
Thank you, Zara, for sharing these interesting slides. And we are very inspiring after hearing this, and also the pre-recorded video. Thanks a lot. And once I presented it to the students here in Antala, they had so many questions, and their first questions was like, why should we learn astronomy? And because Madagascar is still a poor country, we don't have enough infrastructure for that, and not enough funds. So that was their first question. And then, yeah, maybe you can answer it in a better way, because I just answer it just to avoid the meteorite, like, okay. Okay, that's my question.
Yeah. Okay. So I can first answer that question. I know it's a very tricky question in the developing countries, but the best way to look at astronomy is a long-term plan, long-term vision. Remember, all of us can't have this type of fun if there was no astronomy, because of the way we need to image those beautiful galaxies. That means we need the high-resolution camera. So all the development of camera and etc., they were developed inside astronomy. Then later, it is being transferred in everyday life after everything is being developed. So that's one example. The baby diapers, because astronauts sometimes as they are going to space, they have this huge, they want to pee, so they can't pee on themselves. That's why they create the diapers, so that to avoid that. And later, that same technology is being transferred to everyday life, and it is used for babies. And the same for our nice mattress at home where we sleep. The same foam and everything, it was developed in astronomy. The same GPS, you know how much we need GPS in our everyday life. GPS was being developed in astronomy, and then later being transferred in our everyday lives. So the question is really simple. Why do we need to learn astronomy? Because if you want a better life in terms of easier life, then all the technologies, they were being used in being developed under astronomy. Not only astronomy, of course, there are other domains, but that's one domain that really develop many technologies that can be easily transferred in our everyday life. And in terms of Madagascar, when you build an observatory, that means it requires a new roads and stuff. So it also creates jobs and infrastructures. But of course, sometimes it's not as easy to convince. But yeah, astronomy is a long term. It is a long-term investment. It's not like you want a result tomorrow. It doesn't work like that with astronomy.
Thanks a lot for the clarifications, and you are right. And our second question is about the association, because I'm already a member of Galastem, and I tried to convince them, and I hope that they will join it later. But about the other association, as Malagasy Astronomy and Space Science, and what are the criteria to become a member of it, just like an amateur?
Okay, so for MAS, or Malagasy Astronomy and Space Science, there is no big criteria. As long as you are interested, you don't have to be passionate, but if you are interested to learn more about astronomy, then you can join as an amateur member. The call is every year around November. So one thing that I can do, I can send you an email when that time comes, because we only open the application, call for membership every year between mid-November until mid-December. But hopefully, as I said in my talk, now there will be more association. So you don't have to only join Malagasy Astronomy and Space Science, but maybe if you are based in SAVA, then if Hervé, the new future Astro Club leader in Diego and Tsiranana, then I'm sure that is even closer to where you are than the one based in Antananarivo.
Yeah, thank you. And my first question is about the requirements for doing a master degree in astronomy in Antananarivo, because we have so many bachelor students here, and they were asking how to be enrolled in the University of Antananarivo for this kind of master.
Okay, so it's like any criteria to enroll in a postgraduate program at the University of Antananarivo. You need to major in physics and in mathematics. So let's say if you are a first-year student, if you registered as a first-year student at the University of Antananarivo, that means you were under the Faculty of Sciences and the Department of Physics and Chemistry. First year, second year, third year, that's when you choose, am I going to do physics more on physics-related field or chemistry-related field? So when you choose physics, that's when third year, it's more about physics. Fourth year, bachelor's degree, that's when you choose after your bachelor's degree, which means after your license, you choose quatrième année, nuclear physics or geophysics or physique de l'environnement, energetics or astrophysics. So you choose the curriculum of astronomy when you are on your fourth year after your high school diploma. And there you will take one year coursework, and after 1 year, you will start doing your research with a PhD holder based in South Africa. So there is no much criteria. It's really about majoring in physics and in mathematics. And if you need more information, I can link you up with the head of astrophysics at the University of Antananarivo, because myself, I'm just a visiting lecturer helping with the supervision. I'm not permanently affiliated with the University of Antananarivo. Hope that answer your question.
It looks like it did. And Marie-Rolande, if you have any other questions come up, please just give me a wave and I will make sure we get back over to you and the students. So I have a really basic question, I think, for you, Zara, which is, why are you so interested in things so far above us, things that are way up in the sky and beyond?
This question is funny enough. I was interested because I was forced to. I mean, I didn't do astronomy because usually if someone asks, why are you interested in the stars? Then the usual response will be, ever since I was a little girl, then I always look at the stars. But that's not my story. But I'm also proud of my story that when opportunity comes, if you really take it and really work hard, it becomes not only your job, but a passion and a weapon that you use to inspire the others. So for me, I was interested because an opportunity came when I was still a bachelor student at the University of Antananarivo. And that's when the lecturer just said, we need students who goes to South Africa because now we have this big project. Anyone knowing how to speak English, come and talk to me. Back then, I didn't even know how to speak English. I mean, I'm not speaking it properly now, but I couldn't understand. But I was just very bold that if I could learn physics, why can't I learn the language? I mean, English. And that's how I got involved. That's when I started to learn what's astronomy, what do I need to learn. And the more I really got into it, the more I become passionate and I never look back. I'm really grateful that that opportunity arose because I don't think I could implement those two associations if I didn't do astronomy. So if you ask me why am I interested, I would really say it was an opportunity that came to me, but now it's more than a work, it's also a passion.
I would like to first say that your English is fantastic and you're doing an entire complicated scientific presentation in another language, which I could not do. So well done. And
Thank
also,
you.
I appreciate that story because you hear all the time that people knew since they were 5 years old, they always wanted to do something. And most of us don't know that quickly what we want to do because we don't know what's available to us. And I imagine, especially in Madagascar, it may not be clear what opportunities are available depending on who you speak with, who you happen to get in touch with on a research team. So I think it's important to be open to your options, is what you're saying?
Yeah. So for me, at least I knew that I wanted to do anything related to science. That's why I was doing physics, because I wanted to stay by doing things related to renewable energy. You know how much is load shedding in Madagascar, the shortage of electricity. And I thought I will do more in that area. But yes, at least know what you want. And if it still fits more or less your criteria, then go for it. Be flexible, especially if you are still young, because I think that's one of the things I see with my students. I'm the one who teach them, know what you want, but sometimes they are really so in a box that even if an opportunity arises, that I show them, let's say, I say, okay, this is optical astronomy, but no, they do radio astronomy. They don't want to change. But I tell you, if you are still at an early stage of your career, it is even good to explore different areas so that at least later on you will choose that, oh, I liked it better. Because if you only focus on one area, that means that even your expertise, your experience will not be as much as exploring different ways. And that's why when I was presenting this work, I said I have two different topics that are not even related to each other, but I could do the one on radioastronomy, because when I did a postdoctoral researcher after my PhD, I really did something totally different with my postgrad students. That is, yes, back then it really led to depression and stress. But now that I'm a staff researcher, I'm very grateful that it happened, because now I even have more opportunities and more ways to collaborate. So yes, things can be difficult, but always go for it and take time to learn, because if you are willing to learn, you can always get it right.
Wonderful. Oh, it looks like Marie Roland has a couple more questions for you before we wrap up.
Okay.
As I said before, the student had so many questions, and I just select them because there are so many. And my first question is, they asked, how did you collect the data? Because you are citing so many galaxies, and they are so big, and so how long does it last? For years or only for one observation?
Okay.
Yeah.
Okay, so how do you collect data in astronomy? It's like any other science. You first decide you want to observe which galaxies. After you observe the galaxy, you also check which telescope is suitable for the observation. But it also depends which science do you want to conduct. And after responding to all those questions, you choose your telescope. For instance, with the Hubble Space Telescope, that's one of the most famous telescopes. It's there in space. And FYI, it is soon going to be, there is another telescope called the James Webb Space Telescope. So when you want to get data from those type of telescope, you need to apply for time. So you need to submit a proposal. You need to justify why are you worth to be given time to observe the telescope? And you need to also justify how is it going to be conducted, etc. And then when they get back to you, they will be the one to observe for you. But there are also the type of telescopes such as SALT or VLT. It's the one based on Earth. You also need to apply again your time, and then depending on the travel restriction, you as an astronomer can go observe the telescope. And how long does it take? It depends on how much do you want your galaxy to be resolved, and how much do you need for your science. Sometimes you need a 1 hour non-stop. Sometimes it can go for days before you get a beautiful image that needs to be processed. So yes, there are two different type of astronomers. There are the ones that really do the observation. Those are called astronomers. So myself, the telescope I'm using, a Japanese telescope, but there are the ones that you call astrophysicists. They don't do the observation, but they will take the data that have been observed to do their science. So it's just like it says the same thing, but that's the small difference. If someone is called astronomer, it really means that that person did the observation, is doing observation. But if you only do the data reduction and the analysis, then you are called an astrophysicist, but it's more or less the same.
Okay, thank you for that answer. And another question again is, have you already traveled to another planet, like like the moon or the stars?
Well, I'm not an astronaut, I'm an astronomer. So that's another name. An astronaut is the person who will do the traveling outside our own Earth. So me, I stay here, but I travel a lot around different countries. If you are an astronomer, yes, you travel, but in different countries, still in planet Earth. But if you are an astronaut, that's when you will travel to the ISS, the International Space Station, but also to those plans of going to Mars or going back to the moon.
Okay, thank you. That's all from my side.
You are welcome.
Yeah.
All right, so I think that brings us to a nice end right now, 1 hour. Thank you so much for giving us your time this morning, Zara, and teaching us so much, not just about your work in astronomy, but also your work in science advocacy and education, which is so important everywhere. And thank you so much for your time. We really enjoyed it. And thank you everyone else for tuning in.
Thank you, and thanks for invite, and good luck for all the students in SAVA. Please make us proud. Bye.